that like 3 classes has been tough, and second thing like I'm busy in like 2 days, so we missed 2 classes. So anyhow, we will try to cover these topics, and most probably this will be the only like driest topic. Other topics, if possible, will start with tablets. It will be most interesting and most important one. So today we are going to start with filtration. So anyone from the class can explain me what is filtration? Can you see my screen? Sikar, Rajmani Garu, Mannan, Swati. Can you see the screen?
Yes, sir.
Right. Thanks a lot. So we are going to discuss about the filtration. Like centrifugation, like other unit operations, filtration is a separation technique. So here we are trying to separate the substances depending on their size. If we are separating the substances depending on their density, then we are going to use centrifugal force, centrifugation equipment. And luckily, we don't have that in our syllabus. And if you are separating depending on the particle size, then it is filtration. So there are a lot of equipment, very, very important equipments to be discussed in filtration, like SIDS filters, membrane filters, most probably bacterial proof filters, meta filters to be discussed in today's class. Very important and very, very popular plate and frame filter. All these filters we are going to discuss. So let's firstly see what are the objectives of the filtration. The first objective of filtration is what we can say the separation, or we can say purification. When you are separating unwanted particles, then it is generally called purification. And the second is solid recovery, removing the liquid extract from the solid substances after reutilization or something like that. Then separation. Separation is separation is the next important one, and at last improving the like facilitating the product, final product, improving the quality of the final product. So these are the objectives, and the most one which we focus is separation and purification and check code. Can someone give me 2 examples of other unit operations used for purification? Yes, Srika, purification law, distillation, right? Distillation and also purification and separation technique. We studied in previous class, right? Yes. Are you people? See, if you don't respond, I don't take classes. I'll assign somebody else to take your classes. So please respond. Yeah. So distillation is also purification and separation technique. Filtration also purification and separation technique. In distillation, you are separating basing on differences in boiling points, right? Whereas in filtration, depending on particle size. And the governing force in filtration is gravitational force. So that you should remember, right? So yeah, next application, student, very fast we will go by checking the application. Appearance of various pharmaceutical preparations like solutions, mouthwashes, yeah, solutions, mouthwashes, etc. What the appearance improves చేయడానికి will go for the filtration. Next is removing of potential irritants, especially when you are preparing eye drops. Very, very important concept in preparation of eye drops are two things only. One, preparing it sterile. Number two, preparing it free from particles which can what can we say, cause irritation to the cornea, which can bring scratches to your cornea. So adi chala important and you should remember that. So we should be careful. So we should be careful while preparing eye drops. The main intention is filtration. So what here we are suggesting, removing the potential irritants. Second thing, even in the parenterals. Parenterals, though generally the particle size should be smaller, such a way it can pass through the hypodermic needle. If not, they will struck into your blood vessels and can cause embolism, right? So to prevent the blood clotting, we need to filter the product. So removing of potential irritants, for example, various irritants are removed from the eye drops, just as just discussed, and even there are many pastes and other like substances which are supposed to be applied in the mucosal layer, and they can cause irritation there. So to prevent that, we are going for the filtration. Next, for getting the pure product in crystallization, very very important, and actually engineering law, very very important, pharmaceutical engineering law. In our syllabus it's not given, but crystallization, technique of crystallization is called Oswald ripening, and different crystallizers which we use are very important. So crystallization is one of the purification technique, one of the extraction technique. So అందులో to recover the solid material or the final product during preparation of suspensions also, we will go for filtration. That's one of the application. Next major application is to obtain various unit operations. For example, in turbidity, right? Removing of the turbidity, removing of the precipitates to some, we'll use filtration. Colloidal particles preparation, we'll go for this one, and many other things. Next, detecting the microorganisms flow, Guda, filtration is a major step. Can anybody explain me? Chemistry తెలిసిన వాళ్ళు, microbiology తెలిసిన వాళ్ళు, how come bacteriology law, how come filtration is helping? Yes, because on this basis we have an equipment also, filtration equipment. Come on, microbiology deal chesevalu, they should know. Bacterial proof filters will be there. Generally, we will take our product and filter it through bacterial proof filter. We'll take this filter paper, and what we will do, we will try to what can we say, uh, inoculate that filter paper. If that filter paper brings the growth of the cultures, bacteria, then it means the liquid which we filtered is contaminated. After filtering a sample, say for example, I gave you water sample from the tap. I asked you to find out whether it's sterile or not. You will take the bacterial proof filter, you will filter it through it. So any bacteria will be right retained on the filter paper. Take that filter paper and inoculate it, incubate it. If bacterial growth occurs in next 24 hours, it means that water is contaminated. Next, go for the culture studies, go for streaking, find out what kind of bacteria is there, gram positive, gram negative, or whatever. And if I'm giving you the water for injection, pure sterilized water for injection, and I'm asking you to find out whether it's pure or not, or whether it's sterilized or not, you'll simply take that water for injection, filter it using filter paper, I mean bacterial filters, take the filter paper and inoculate it. If it's not showing any growth, it means your water for injection is good. So allow to find out whether your water is contaminated, whether your final product is sterile or not. One of the method of testing bacterial presence is filtration technique. So దీనికి వాడే filtration equipment also we'll discuss. SIDS filters, membrane filters, bacterial filters, everything we are going to see in this class. So that's very very important. ఇంకా filtration ఎక్కడ వాడతామండి? I hope everybody know air condition, ACs you have seen. AC service people, if you call, what they'll do, they'll remove the indoor unit, collect the filters, and they'll clean the filters. You know what is the name of that filter? HEPA filters, high efficient particulate air filters. These HEPA filters are well known to filter the air, to filter the quality of the air, to give us pure air by like preventing it from the other dust particles and other particles present in it. So HEPA filters are very very important in aseptic processing, in monitoring the air. Okay, so that also a very important application, especially laminar airflow flow, laminar benches flow, aseptic lines flow, aseptic rooms flow. We are going to use HEPA filter. See, while preparing the parentals, previously they used to have aseptic rooms. I hope you know what are the aseptic rooms. Class 100 rooms, class 1000 rooms, class 10,000 rooms. Maintaining this room is costly. Nowadays, entire room is not prepared aseptic. Only the line ante a basic platform on which you are preparing your formulation, or you're preparing the parental, our platform will be sterilized. So it's called aseptic line. So only filling area, packing area, sealing area on the working platform will be sterilized. So అలా చేసేటప్పుడు అందులో పంపించే air ని, if you want to send the quality air, you will use HEPA filter. Very very important to sterilize a room. Generally three things to be monitored. Please pay attention. Number one, air entering into the room. Number one, two, material entering into the room. Number three, persons entering into the room. These three things they monitor chest the aseptic processing is possible. And air entering in the room can be monitored how by closing all the doors and windows and allowing air only entering through HEPA filters. So number two, what we will do is we will control the material entering into the room. The material entering into the room, especially in the aseptic room, should be treated properly, should be quarantined properly, should be kept for some time in incubation period and check whether any bacterial growth is there or not. When this is perfect, then only that sterilized quarantine raw material is sending inside the aseptic room. Third thing, and the people entering into the room, how we are going to monitor people entering in the room? We will give them protective gear, we'll give them headscarf, we'll give them like face mask, we'll give them shoe protectants, we'll give them aprons, we'll give them gloves, everything in exchange room. We'll make him like an alien. We don't allow anything from his body, any body like dead cells, hair, anything, his saliva, anything should not be transferred into the room. So we will fully protect him and we'll pass him from exchange room into the manufacturing room. So these three are the basic techniques how we will monitor the sterile conditions. Yeah. Okay. Let them sit for open. Okay. So the next important student and the bacterial filters and Japama. This is the very important point. 0.2 micrometer size untene it can filter the bacteria. Lepothe it's difficult to filter the bacteria. See, we have studied in sterilization techniques how to cope up with the bacteria, how to remove the bacteria. We studied a lot, like starting from the BPharm first year or diploma first year. We know sterilization techniques like heat sterilization, moist heat sterilization, using of oven, using of radiations, right, using of fumigation, using of incineration. But there is another technique of removing bacteria, like what we discussed is filtration. So filtering through bacterial proof filters whose pore size will be zero point 0.2 microns. Please note it down. I don't know whether you're following or not. Please note it down. 0.2 micrometer size untene బ్యాక్టీరియాని ఫిల్టర్ చేయగలుగుతుందండి. See, bacterial proof filters. How is it possible? 0.2 micrometer size undali. So that's the next important thing. Next application, bulk drug production lo kuda we are going to use filtration techniques. Liquid oral preparations lo also we are going to use filtration techniques, especially while preparing elixir, eye drops, syrups, right? All these things lo kuda aromatic waters lo kuda filtration is a major technique in order to separate, purify the material what we are going to obtain. So these are applications of filtration, and especially you should remember during separation, purification, crystallization lo pure yield radaniki, purification of air and bacterial proof filter. These five applications are very 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 important things to be taken in today's class is HEPA filter. HEPA, high efficient particulate filtrates. Please write down everywhere in laminar air flows, in your air conditions, everywhere we are going to use this HEPA filters. Very very important. And bacterial proof filters and membrane filters, six filters lo we use 0.2 micron size. Already I explained you in the previous class also ki manam purity lo bacterial proof filters untayi, అందులో కూడా pore size will be 0.02 microns. Even the conventional old candle filters which we use, Rama filter, Ganga filter లాంటివి ఉంటాయి కదా, అందులో కూడా ఆ asbestos sheets లో pore size ఎంత ఉంటుంది? 0.2 microns. 0.2 microns pore size ఉంటేనే it can filter the bacterial filter. మన normal Vatman filter paper, regular filter paper used in a lab is not suitable for filtering this thing. Okay, chalo. So these are applications of filtration. I hope you have seen. Basic theoretical concepts చూడాలండి. Rate of filtration ఎలా measure చేయాలి? Rate of filtration can be measured by driving force in the filtration by resistance, right? So rate of filtration ఎలా తెలుస్తుంది? Volume of filtered in liters passing per unit time, dV by dt will give me the filter rate. Okay, driving force for the filtration is pressure you are applying in upstream. Generally vacuum apply చేస్తాము, ఎంత vacuum apply చేసాము, ఎంత pressure apply చేసాము అనేది driving force, right? So resistance, how to calculate resistance? Pressure upstream minus pressure downstream by the length of capillaries. So these are the series of filtration మనకు అంత అవసరం లేదండి, depth. So we are not going into the detail. Theories of size reduction important. That's why we discussed, right? I hope you remember three theories, like Higgs theory, Bonds theory, Rödinger's theory, and size reduction. There it's important. ఇక్కడ మనకు అంతగా అవసరం లేదు, so we are not focusing. But you should know to understand the factors affecting the filtration. ఈ ఈక్వేషన్స్ తెలుస్తే మీకు తెలుస్తుందండి. Just for your understanding, let's see one like costless equation. If you see velocity of or rate of filtration is directly proportional to delta అని ఎక్కడ వచ్చినా కానీ చేంజ్ అండి. సో చేంజ్ డెల్టా పి ఇస్ అ చేంజ్ ఇన్ ద ప్రెషర్ ఆర్ ప్రెషర్ డిఫరెన్స్ అక్రాస్ ద ఫిల్టర్ మీడియా. అంటే ప్రెషర్ డిఫరెన్స్ ఎంత ఎక్కువ ఉంటే అంత ఫాస్ట్ గా ఫిల్టరేషన్ అవుతుంది. ఆర్ స్క్వేర్ మీన్స్ ఆర్ స్టాండ్స్ ఫర్ ఇయర్ రేడియస్ ఆఫ్ ద capillaries, right? So directly proportional. The greater the radius of the capillaries, the faster will be the filtration rate. And L stands for the thickness. Thickness of the filtration material is inversely proportional. అంటే ఎంత థిక్ గా ఉంటే అంత స్లోగా ఫిల్టర్ అవుతుంది. And neta always stands for viscosity. So you should remember these values, right? Delta P stands for change difference in pressure. Then L stands for thickness. Neta stands for viscosity. So the relationship between the difference in the pressure, length or thickness of the capillaries, radius of the capillaries, thickness of the filter medium, and viscosity of the liquid is being used to calculate or to find out the rate of filtration. ఎందుకు ఇవి పైన పైన చెప్తున్నట్టు మళ్ళీ ఫ్యాక్టర్స్ ఎఫెక్టింగ్ ఫిల్టరేషన్ లో వీ నీడ్ టు నో. డాసెస్ ఈక్వేషన్ లో కూడా అలానే చూడండి. అగైన్ యూ కెన్ సీ డెల్టా పి అంటే ఏం చెప్పానండి ఇప్పుడే, చేంజ్ ఇన్ ద ప్రెషర్ ఆర్ ప్రెషర్ డిఫరెన్స్. ఏ ఈజ్ హియర్ సర్ఫేస్ ఏరియా ఆఫ్ ద పోరస్ బెడ్. అక్కడ ఏమన్నాడు క్యాపిలరీ ట్యూబ్ రేడియస్, ఇక్కడ సర్ఫేస్ ఏరియా తీసుకుంటున్నాం. నీటా అండ్ విస్కాసిటీ స్టాండ్స్ ఫర్ సేమ్. నీటా స్టాండ్స్ ఫర్ విస్కాసిటీ, ఎల్ స్టాండ్స్ ఫర్ థిక్నెస్ ఆఫ్ ద ఫిల్టర్ మీడియం. సో యూ కెన్ సీ ఎప్పుడు కూడా ఫార్ములాలో చూడంగానే గుర్తుపెట్టాలండి. నామినేటర్స్ లో ఉంటే డైరెక్ట్లీ ప్రపోర్షనల్, డినామినేటర్ లో ఉంటే ఇన్వర్స్లీ ప్రపోర్షనల్. నౌ రేట్ ఆఫ్ ఫిల్ట్రేషన్ ఇస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు surface area of the porous bed, directly proportional to differences in the pressure head, inversely proportional to viscosity, inversely proportional to thickness of filter media or thickness of the cake, right? That's important. So adi gurtupeట్టుకోవాలి. Next, Poisson's equation lo also shown the relation between all these substances, like delta P is the pressure drop, right? K is Poisson's constant, and epsilon is the porosity of the cake, area is the filter medium, and the surface area of the particles. So basically, rate of filtration is revolving around all these things. Entandi viscosity of the liquid, thickness of the filter medium, the radius of the diameter tubes, differences in the pressure head. So E parameters to factors affecting filtration is revolving. Please note down differences in the pressure head, thickness of the filter media, radius or the surface area of the capillaries are the important factors governing the rate of filtration. Okay, so let's jump into the factors. Pressure, right? Viscosity, ఇప్పుడు మీరు చెప్పాలి డైరెక్ట్లీ ఇన్వర్స్లీ ప్రపోర్షనల్. సర్ఫేస్ ఏరియా అండ్ టెంపరేచర్. So these are the factors which are affecting the filtration. ఇంకేమున్నాయి, particle size is also a factor, right? Particle size పెద్దగా ఉంటే slower filtration. Pore size of the filter medium directly proportional. Thickness of the cake directly proportional. Porosity of the cake directly proportional. Characteristics of the slurry. These are the factors affecting filtration. Please note it down. Pressure, viscosity, surface area, temperature, particle size, pore size, thickness of the cake, porosity of the cake, and characteristics of the slurry. Please note it down fast. Chaka chaka రాసేయాలండి. రాస్తున్నట్టు నాకు you should on your camera and show me whether you're writing or not. Hello, fast. Switch on your camera and show me whether you're writing the factors or not. So we already discussed directly. Mahesh sir, directly proportional. Particle size, yeah, good. Others, pore size directly proportional. Thickness of the cake inversely proportional. Second is Kali undadu. Raj sir, Asma madam. మ్యాథ్స్ బి అను ఫిజిక్స్ పెండింగ్ ఉంది, మీరు చూడకండి, వాళ్ళని కంప్లీట్. ఓకే, ఓకే, ప్లీజ్ ఫాలో అప్స్. సాహిల్ పేడ్, వాళ్ళ అమ్మ ముచ్చి పేడ్. Thickness of the cake is inversely proportional. Porosity of the cake is directly proportional. In that case, right? So factors చూసుకోవాలండి. Temperature is always directly proportional for filtration. ఎంత temperature పెంచితే అంత filtration easy అవుతుంది, right? And the surface area is directly proportional. Viscosity is inversely proportional. Pressure is directly proportional. Please note it down. And ఈ త్రీ ఫార్ములాస్ చూస్తే మనకు అర్థమైపోతుంది ఏది డైరెక్ట్లీ ప్రపోర్షనల్, ఏది ఇన్వర్స్లీ ప్రపోర్షనల్. ఎప్పుడు కూడా ప్రెషర్ పెంచితే filtration increase అవుతుందండి, సో డైరెక్ట్లీ ప్రపోర్షనల్. Viscosity, the more viscous, viscosity is resistance to flow, slower will be the flow, so obviously rate of filtration will be slower. Surface area lo ante directly proportional, greater the surface area, greater the chances of filtration are there, so speed will be more. Temperature also directly proportional, because increasing in the temperature is decreasing viscosity, people lo chavatamandi. So that's the reason why this is happening. Then temperature is done. Then particle size is directly proportional. Smaller the particle size, greater will be the filtration. Particle size of filtration rate. Particle size of capillaries అయితే greater the capillaries, greater will be the rate of filtration. Right? Thickness of the cake directly proportional, because the more the thicker the cake, the more filter papers you use, the more this is called filtration aid. The more faster the particles will be filtered. So next, Andy, we are jumping into the filtration aids. Already tells chala important underside. Kristallgar is a very important filtration aid. Talc is a filtration aid. Fuller's earth is very good filtration aid. Asbestos mana filters lo untundi is a filtration aid. Charcoal and bentonite and paper pulp, these are the filtration aids. Generally presence of filtration aid increases the rate of filtration. We are not going into much detail because we need to check the other equipments. So please note down the examples of filtration aids: Kisselgar, talc, charcoal, asbestos, paper pulp, bentonite, and fuller's earth. Noted? Noted. Shall we move forward?
Yes, sir.
Yes, thank you. So next, very important are lot of filter mediums, characteristics, types of filter papers. Some లేదండి, directly we are going into the see. ఒకసారి చూడండి, it will help you. Types of filtration aid లో filter paper we use. This is very common. Then membrane filters అని ఇప్పుడు చెప్పండి చూడండి. Membrane filters are very important. They are generally cellulose derivatives and they are used in preparation of bacterial proof filters అండి. Very important, and their pore sizes are very important. చూడండి 0.05 to 14 microns దాకా రాగలుగుతుంది, and 50 to 200 microns దాకా ఉంటుంది. So it's very important. Cotton can also be used in filters, especially hospital pharmacy lo, while giving injections. Cotton is generally inserted and they are taking out to prevent the material. So adi non-absorbent cotton వాడతాము, absorbent cotton వాడమండి. Next, glass wool is also used as a filter medium. Asbestos is very important material used as a filtration medium. Sintered glass filters, ఇది కూడా చాలా important. I'll show you the photos also how sintered glass filters will be there. And మనకు Chamberlain filters, these are the general filters we use. చలో equipments లో very important equipments, if anybody can know this, plate and frame filter చాలా important industrial settings లో యూస్ చేయడానికి. And meta filters are very important. They are entirely made up of metal. Cartridge filters are very important. మన ప్యూరిట్ లో cartridge filter ఉంటుందండి. Membrane filter and cis filters are also too important because they are generally used as bacterial filters. So these are certain filter equipments which we are going to see. And అందులో చాలా important is plate and frame filter. We will see the entire setting of this today. And membrane filters and cartridge filters. So ఇది ఖచ్చితంగా గుర్తుపెట్టుకోవాలండి. So let's directly jump to the membrane plate and frame filter. As name suggests, plate and frame filter contains two plates and one frame. Two plates లో అండి, ఒక్క plate is generally idli patra మీరు చూస్తే it is easier అండి to understand. Not the idli patra present in your home, but idli patra present in hotels. ఎందుకంటే ఆ ఇడ్లీ పాత్ర పైన దే విల్ యాడ్ ఎ క్లాత్ అండ్ ఆన్ దట్ క్లాత్ దే విల్ యాడ్ ఇడ్లీస్ ఐ మీన్ ఇడ్లీ బ్యాటర్. అలా దిస్ ఈస్ లైక్ ఇడ్లీ పాత్ర విచ్ కంటైన్ grooves. On that grooves you will add this filter medium, the cloth which holds idli laga, this one. And to fix that, this frame we will have. So in order to identify them, we will identify them using certain dots in procedure. You can see one dot, two dots, one dot, two dots. One dot is a plate, two dots is a frame. Plate, frame, plate, frame, plate. So the arrangement is 1:2:1:2:1. అంటే ఫస్ట్ ప్లేట్ పెడతాం, దాని తర్వాత ఫిల్టర్ మీడియా పెడతాం, దాని తర్వాత ఫ్రేమ్, మళ్ళీ ఫిల్టర్ మీడియా, ప్లేట్, ఫ్రేమ్, ఫిల్టర్ మీడియా, ఫ్రేమ్, అట్లా ప్లేట్ ఫ్రేమ్ ప్లేట్ ఫ్రేమ్ ప్లేట్ ఫ్రేమ్ అరేంజ్ చేసుకుంటూ వెళ్తాం. సో ద రేషియో ఇందులో ఫస్ట్ ఇంపార్టెంట్ గుర్తుండాల్సింది రేషియో అండి. 1:2:1 మళ్ళీ (2:1) ఇలా. సో నేను అక్కడ వేసాను చూడండి, 1:2:1:2:1. సో దిస్ ఇస్ ద రేషియో జనరల్లీ యూజ్డ్ ఇన్ ఫిల్టర్ మీడియం. అమ్మ 8:30 తక్ వచ్చిన 8:30 తక్ అవుట్. ఓకే, సో ప్లీజ్ నోట్ డౌన్ ద అరేంజ్మెంట్ సో దట్ యూ కెన్ అండర్స్టాండ్. సో 3 పార్ట్స్ లో అండి, 3 పార్ట్స్ ఇందులో ఏమేమి ఉంటాయి? ప్లేట్, ఫ్రేమ్, ఫిల్టర్ మీడియం. Plate, frame, filter medium, right? So plate and frame filter, you can see plate and frame filter press flow consists of two major parts, plate and frame, made up of aluminium, and open space is present within the frame. The slurry reservoir generally having slurry inlet. So how to identify construction lo dots? The part should be changed in sequence: plate, frame, plate. So arrangement ela andi, 1:2:1:2:1. Please note down this arrangement. మళ్ళీ క్లీనింగ్ అప్పుడు అరేంజ్మెంట్ మారుతుందండి. దిస్ ఇస్ ద క్లీనింగ్ అరేంజ్మెంట్. 1:3:3:1:2:3. ప్లీజ్ నోట్ డౌన్. క్లీనింగ్ అరేంజ్మెంట్ లో 1:2:3:1:2:3 ఇక్కడ రాశాడు. మరి ఇక్కడ 3 ఏంటండి? ఇట్స్ ఎన్ క్లీనింగ్ ప్లేట్, ద ప్లేట్ విచ్ కెన్ send the water with high pressure so that the cake formed on the filter media can be cleaned. So adi, so this arrangement is called cleaning arrangement. 1:2:3, 2:1:2:3 goes on. మళ్ళీ ఇక్కడ 3 వచ్చింది కదా, మళ్ళీ 2:1 అలా వెళ్తూ ఉంటుంది అన్నమాట. ఓకే, 1 2 3 2 1 2 మళ్ళీ 3 2 1 3 2 1 3 2 1 ఇలా వెళ్తుంది. ఓకే, ఇక్కడ ఇచ్చేయండి 1:2:3:2:1 మళ్ళీ రైట్, 3 తర్వాత 2 1 మళ్ళీ 2 3 1 2 3 ఇలా ఇలా సీక్వెన్స్ గా వెళ్తుంది. సో దిస్ ఈస్ క్లీనింగ్ అన్నమాట. సో లెట్స్ సీ ద వర్కింగ్ ఫాస్ట్ గా. యూ కెన్ సీ దిస్ ఇస్ ద కన్స్ట్రక్షన్ వాట్ వీ హ్యావ్ సీన్. వర్కింగ్ లో filtration is the one step, washing or cleaning is the one step. Filtration lo we are going to use this arrangement 1:2:1:2:1 అంటే plate frame plate frame plate frame. Whereas washing lo we are going to use 1:2 మళ్ళీ మధ్యలో 3 వస్తుంది, మళ్ళీ 2 1 2 1 3 అలా. దిస్ ఇస్ ద arrangement 1 2 3 2 1 2 3 ఇలా వస్తుంది. This is washing arrangement. So let's see the working. Very simple and if the filter cake is working low, the slurry to be filtered in the frame feed, it was sent and then reaches to the plate surface, single dot in the figure, by passing through the filter media. చూడండి మీకు కనిపిస్తలేదేమో ఇక్కడ. Oh sorry. Yeah. So how slurry is entering? స్లర్రీ ఇక్కడ ఎంటర్ అవుతుంది, స్లర్రీ ఇక్కడ 2 డాట్స్ ఇందులోంచి ఇక్కడికి వస్తుంది ఇలా. సో 2 sides ఆఫ్ ద ఫిల్టర్ మీడియం కేక్ ఫామ్ అవుతుంది చూడండి. సో దిస్ ఫిల్టర్ మీడియం లో ఇటు నుండి కేక్ ఫామ్ అవుతుంది 2 sides. సో యూ కెన్ సీ హియర్ a filter cake formed by the solid particles is retained on the frame. Since filtration occurs on the both sides, just now I said and the cake thickness is half of the frame thickness. Thus, two filter cakes are formed with meets in the center of the frame. Pavan, sir, Pavan, parents are. Okay, so normally the filter cake, parents for 5 minutes. So 5 minutes class. So normally the filter cake of and slurry will have no optimum thickness, which depends on the solid content in the slurry. So generally, we are sending the slurry from the two dotted plate. Then what frame? Then what's happening? The liquid is passing through this filter media. Cake is formed on the both sides. Filtration. So filter passes through the outlet by draining between the projections on the plate. Filtration process, the resistance to filter cake increases to the decrease the filtration. So thickness and ఎక్కువ అవుతూ పోతే అంత స్లో డౌన్ అవుతూ ఉంటుంది filtration. So we need to halt the filtration process and go to the washing process. Washing of the filter cake is required to be washed. Ordinary plates and frame plates are not satisfactory. Sometimes the flow is almost stopped as two cakes built up. So Danivalla, what we'll do, we will arrange the three dotted plate. Three dotted plate లో ఏముంటుందండి? You have the provision for cleaning. So this washing plate are marked by the three dots. Half the wash plate has the connections from the wash water channels to the water surface. So when the filtration completely halts, when the rate of filtration slows down, we will insert the third plate, that is the washing plate or the cleaning plate. So three plates లో ఒకటి frame ఒకటి plate. So frame filter press అంటున్నాం, frame and plate filter press అంటున్నాం. Okay, so the arrangement sequence of the plate and frame is as shown in the figure. 1:2:3, 2:1:2. If this is the arrangement, please note it down. Sir, 5 minutes, class will finish, then I'll talk to them. If the student is below 10th class, ask him to write the test, conduct the test. Meanwhile, I'll talk to them. Yeah. So you can see the figure working. Filtration continues normally until the frame was filled with the cake. Like this is what happening. 10th also test. Yeah. First they'll write test, mathematics test. Right? Then during the washing of filter cake, the outlets of washing plates, three dots are closed. So water obtained after washing these channels is pumped into the washing channels. The water reaches the surface of the washing, that is three dot plates, by passing through the inlet. So ఇందులో మీరు క్వశ్చన్ కాంపిటేటివ్ ఎగ్జామ్ లో అడిగేది రెండండి, ప్లేట్ అండ్ ఫ్రేమ్ ఫిల్టర్ లో అరేంజ్మెంట్. ఇది ఈ రేషియో 1:2:1:2:1 ఒకటి, ఇది ఒకటి. ప్లీజ్ నోట్ దెన్ 1:2:3:2:1, 2 తర్వాత మళ్ళీ 1:2:3:2 వస్తుంది, మళ్ళీ 1:2:3:2 వస్తుంది. అలా గుర్తుపెట్టుకోండి. 1:2:3:2, మళ్ళీ 1:2:3:2, 1:2:3:2, 1:2:3:2, అలా గుర్తుపెట్టుకోండి. ఇట్ విల్ బి ఈజీ. 3 is the washing plate, 2 is the frame, 1 dot is the plate. ఇది గుర్తుపెట్టుకోవాలి. ఈ two things if you write, this is done. Plate and frame filter. Please note it down. 1 dot is plate, 2 dot is a frame, 3 dot is the washing plate. Please note it down fast. Done. If you are noted, we'll move forward.
Yes, sir. Completed.
Yeah, thanks. Sir. So uses and application, student. It is used in filtration of slurries containing solid up to 5%, used in collection of the bismuth salt, especially ఇది గుర్తుపెట్టుకోవాలి, penicillin preparation లో removing precipitate proteins from insulin, sorry, not penicillin, insulin preparation లో it has a very important role, so that you should remember, right? So there are a lot of demerits, Sunday. It's a batch process, takes a lot of time. Cake form hypothesis filtration rate is completely halted. Lot of laborious process, take a lot of time for the cleaning, and it is used slurries having solids less than 5% flow వాడాల్సి వస్తుంది. So all these are disadvantages or limitations of plate and frame filter. So three things to be remembered in plate and frame filter: arrangement in washing period and filtration period. So 1 is to 2 is to 1 is to 2 is to 1 is to 2 is working in filtration, and in washing 1